Hello, welcome back. A new topic we're gonna do is regarding loci. We did something way back at the beginning of the scholastic year. Loci is when we have one or other points that we trace their movement. Okay. For this topic, we're gonna design what we call Archimedean spiral. So please prepare a fresh paper, do a border, and write in the title block Archimedean spiral. Okay, so basically, what's this about? Archimedean spiral is the study of a moving point. The moving point is traveling in straight line, what we call the linear velocity. While is moving in a straight line, linear velocity is rotating with the same speed, which is called angular velocity, and that would create what we call the Archimedean spiral. Here I'm gonna show you an animation of what I'm talking about. Look, in this diagram, here we have the point which is moving straight line, linear velocity, at the same time is rotating. So that is the profile which we call the Archimedean spiral. Okay, now I'm gonna show you how we're gonna plot this particular curve. Okay, find the midpoint of the whole paper, and we're gonna draw a line. We're gonna call it line AB. Line AB, we're gonna do it 120 millimeter. Okay, so find the midpoint of the A3 paper and draw a horizontal line, construction line 120 millimeter, and label it AB. Okay, that is gonna be the profile covered with the given point. To make things easier, I did line AB 120 millimeter on purpose because the distance traveled, always we need to divide it into 12. So for this case, 120 division by 12 obviously give us 1 centimeter each point. Otherwise, let's say AB is 100 millimeter, then we have to use division of a line to divide from A till B into 12. Okay? So the situation is the point is moving from A till B. So what we need to do, from point A, we need to draw lines covering a full rotation. Okay? As if when we divide the circle into 12, it's the same thing. The angles are the usual, 30 degrees and 60 degrees. Okay? So, if the Archimedean spiral starts from A and travels to B, the 12 divisions we need to place them at A. If the Archimedean spiral it starts from B and ends at A, the 12 divisions we have to do them at point B. Okay? So, for now, always construction line. Next step. When we have all the divisions, okay, I'm gonna show you over here because this is the ready-made product. I'm gonna show you the first number of arcs we need to do. So I'll explain this drawing gradually. Okay, the 1, 2, I'm gonna remove it. Okay, so focus here. So when you divided from A till B into 12, we said we had a number of points which are 1 centimeter apart. I'm gonna do like this so you'll understand much better. So these are the 12 divisions. In this case, as I said, you can each point just do it 1 centimeter apart. If from A till B is different than 1 to O, we need to use division of a line. So remember, A, the point is traveling from A till B. So all we need to do, open compass from A till the first point, and we do an arc stopping on the first radial, which is the line at an angle of 30 degrees. Okay, I'm gonna do a small circle to represent the points. Okay, so you can just do a tiny point with the pencil. So as I said at the beginning, the point is traveling from A till B. So the initial point, when this was at rest, the point was over there on the origin, on point A. It moved 1/12, and we're gonna the point on the first radial. 2/12, we have the point over there. 3/12, we have the point over there. And we keep going. I'm gonna show you. These you need to do them obviously with a compass, always construction. Okay? Always the best way not to get confused. Mark each point in every step you take. We have a point there, we have a point there. So every time you do the compass, make sure you stop on the respective radial and mark it with the point. The point with a bit bold, so when we do the curve, which is gonna be freehand. Okay? So the points will guide you how to do the best possible curve. So here we have all the points. This is showing that the point traveled from A till B in linear velocity, at the same time is rotating at angular velocity. Freehand, this is gonna be the profile. So basically, that is the Archimedean spiral. I'm gonna show you again the profile. We have movement here. That is always happens with locus or loci. To keep you back on track, the topics we covered this year regarding locus were moving mechanisms, where we learned about slider, pivot, etc., etc. We did the helix as well, where we had the point rotating on a cylinder, and we also covered the cycloid, which was a fixed point on a rotating circle. So this makes part of the same family. All right. So basically, this is the answer. Here, using 5 or 3 millimeter, right? Linear velocity equals angular velocity, and write 1 turn. Okay? Take time to design this Archimedean spiral curve. Thank you.